All right, in this video, we are going to work through this example. We want to find the critical numbers of this function, f of x equals x to the 8th, x plus 8 to the 6th power times e to the 9x plus 2. Okay, so the first step is to find the domain of f. We need to know that. So looking at this function, we can see that it is composed of three different parts. It has this x plus 8 to the 6th power, right, which is a polynomial. It has this 9x plus 2, which is also a polynomial. And then it has this e to the x part right here. So 9x plus 2 and x plus 8 to the 6th, their domains, since they are polynomials, is all real numbers. Okay, so, and then e to the x, which is the function that this 9x plus 2 was plugged into, right? For if you look, right, that e to the 9x plus 2 is the result of taking 9x plus 2 and plugging it in for x right here. In other words, it's the composition of 9x plus 2 and e to the x. And the domain of e to the x just by itself is all real numbers. Okay, so because every single part of this function was all the pieces of this function have domain, all real numbers, and the way this was put together was with composition and multiplication. There's no division involved. That means that the domain of this function is also all real numbers. Okay. Okay, so next up we have to take the derivative. All right, so looking at this function, we can see that it is made up of two parts. We have this x plus 8 to the 6th power and this e to the 9x plus 2 being multiplied by each other. So this is a product rule problem primarily. Okay, so we're going to use the product rule to take the derivative. First off, I'm going to take the derivative of this x plus 8 to the 6th power. So looking at that x plus 8 to the 6th, that is a chain rule problem, right? The inside part is x plus 8. The outside part is x to the 6th power. In other words, this function x plus 8 to the 6th power was created by taking x plus 8 and plugging it into x to the 6th. Okay? And so we have to use the chain rule to take the derivative of this part. So the chain rule says to take the derivative of the outside part, which is 6x to the 5th, right? And x to the 6th. And then plug the inside into the derivative of the outside. So instead of it being 6x to the 5th, it is going to be 6 times x plus 8 to the 5th power. And then the last step of the chain rule is to multiply by the derivative of the inside part. The derivative of x plus 8 is just 1. Okay, so I'm going to multiply by 1. So we took the derivative of x plus 8 to the 6th. Going back to the product rule says once you've taken the derivative of this first function, then just multiply by the second function. Whatever it is, just multiply by it. All right, and then the product rule says put a plus. And then the function that you took the derivative of in the first go round, this x plus 8 to the 6th, now just rewrite it, don't do anything to it. And the function that you left alone in the first round, which was the e to the 9x plus 2, now you want to take its derivative. So we need to take the derivative of e to the 9x plus 2. Again, that is a chain rule problem. Okay, so the chain rule problem, right? We need to identify the inside and the outside. For these exponential functions, e to the x, the inside is generally the exponent part. So the inside is going to be 9x plus 2. The outside is e to the x. Okay. So once you know the inside and the outside part, you would just run through the 3 steps of the chain rule. Step number 1, take the derivative of the outside function. So the derivative of e to the x is e to the x. Okay. And step 2 of the chain rule is to plug the inside into the derivative of the outside part. So take this 9x plus 2 and plug it in for x. We would get e to the 9x plus 2. All right. And so generally, a lot of times with these e to the, if you have e to some function and you want to take the derivative, then the first 2 steps of the chain rule just amount to rewriting what you've got. But don't forget the third part of the chain rule. The third part of the chain rule says you have to multiply that by the derivative of the inside part. And the derivative of 9x plus 2 is just 9. Okay. All right. So we are done taking the derivative. What we've got to do now is do some algebra to simplify this out. Okay, so I'm just going to do some very basic algebra here. In fact, it really doesn't amount to nothing but just amount to anything but just cleaning this up slightly. Oops, I wrote a 5 there instead of an 8. Okay, so I have 6x plus 8 to the 5th times e to the 9x plus 2, and I just really brought this 9 over here. All right, so what I'm going to have to do is to, I want to simplify this a little bit more and then set this equal to 0 and solve. So I'm just going to go ahead and simplify. And what you want to do here to simplify this out is to factor it out completely. You want to look at these 2 terms, right? This term right here and this term right here, and see what they have in common, and then factor out as much as you possibly can out of there. Okay. All right, so looking at the 2 numbers, I have a 6 and a 9. Greatest common factor there is a 3. So I'm going to factor that out. And then x plus 8, this has 5, this term has 5, this term has 6. So they both have at least 8. I mean, at least 5 x plus 8s. Okay. And then both terms have this e to the 9x plus 2. All right, so I'm going to factor that out as well. Then see what you have left over once you factor that out. So out of this first term, I have a 6. I factored out a 3. So 6 divided by 3 is going to leave a 2 inside there. All of these x plus 8s have been factored out, and this e to the 9x plus 2 has been factored out as well. So all that's pulled out. Then I'm going to have this plus. Then here, when I have this 9 and I factor out a 3, 9 divided by 3 is 3. So I'm going to have a 3. I'm going to have one of these x plus 8s left over. And that's it. That e to the 9x plus 2 is factored out. All right, I'm going to keep simplifying. And I have 3x plus 8 to the 5th power times e to the 9x plus 2. Inside these brackets, I'm going to have 2 plus, and I'm going to distribute, and I'll get 3x plus 24. All right, keep simplifying. So I have 3 times x plus 8 to the 5th e to the 9x plus 2 and 3x plus 26 here. And that's it. So the trick on these problems with e to the x is to factor those out completely. All right, so I have the derivative. It's completely simplified. Next step is I am going to set that entire derivative equal to 0 and solve that out. So that will tell me where the derivative is equal to 0. I would also need to find where the derivative is undefined, but the domain of the derivative is all real numbers for the same reasons that we talked about back when we were finding the domain of the original function. All of these are polynomials and e to the x, and it's all multiplication in one composition here. So there aren't going to be any critical numbers where the derivative is undefined. All right. Okay, so solving this equation is going to give us our possible critical numbers. All right, so now what I need to do is I've got this equation completely factored, right? I am multiplying these three things. So I'm multiplying this, this, and this, and I wind up with 0, okay? So if you multiply three things and you wind up with 0, well, then that means that at least one of those had to be 0. All right, so that means that either 3 times x plus 8 to the 5th power is 0, or e to the 9x plus 2 equals 0, or 3x plus 26 is equal to 0. Okay, and I just need to solve each of those three equations. Again, that will give me our possible critical numbers. So I'm going to start with the easiest one, which is this one right here, the e to the 9x plus 2 equals 0. It's the easiest one because there is no solution to this. The reason is because e to any power is always going to be a positive number. It can never be 0. So the fact that this exponent is 9x plus 2 doesn't make any difference at all. It could be anything up there. It doesn't matter what the exponent is. If you have e to a number, it will never wind up to be 0. Okay. So there's no solution to this one. All right. All right. Next up, I need to solve this equation over here. 3 times x plus 8 to the 5th equals 0. So the first thing I'm going to do is divide both sides by 3 to get rid of that 3 out in front. And when I do that, I get x plus 8 to the 5th equals 0. So let me write that over here. So x plus 8 to the 5th power equals 0. Okay, so now I need to solve x plus 8 to the 5th power equals 0. Okay, well, I have a x plus 8 being raised to the 5th power, again, it equaling 0. Well, if you raise a number to the 5th power and get 0, the only way that that can happen is for the number that you are raising to the 5th power to be 0, right? So that means that x plus 8, if this is true, right, x plus 8 to the 5th power is 0, the only way that that can happen is for x plus 8 to be 0 itself, right? Because of the fact that if x plus 8 is positive, a positive number to the 5th power would be positive, and if x plus 8 is negative, a negative number to the 5th power would be negative, right? So the only way it could come out to be 0 is for the number itself to be 0. And so I get x equals negative 8. So negative 8 is a possible critical number. All right, next up I need to solve 3x plus 26 equals 0. And that's straightforward. And so I get x equals negative 26 over 3. All right, so I have my solutions. It's negative 8 and negative 26 over 3. Okay, so those are my possible critical numbers. What I need to do, right, to check to get the actual critical numbers is go back and check the domain, okay? These numbers, the possible critical numbers, have to be in the domain of the original function to be an actual critical number of f, okay? And you can see that here the domain is all real numbers, so that means, yes, negative 8 is in the domain of f, negative 26 over 3 is in the domain of f, so they are both critical numbers. Had one of them not been in the domain, then it would not be a critical number. So the answer, right, on this problem is negative 8 and negative 26 thirds.